Now, let me, instead of taking n or whatever, let's look at it from another way. Now, this will possibly clear everything. Guys, I do not want an exact answer for this question. My question is, I have a number 84 and I divide it by 3. I don't want you to give me the exact remainder. No. Tell me what the possible remainders can be.
So it is completely divisible, this one.
Okay, so what are the possible, what is the remainder? It is 0. Okay.
0.
For example, I'd say 88 by 3. What are the possible remainders? See, even though this is 0, I want you guys to tell me what are the possible remainders. 3 is the divisor. What did we understand in the concept?
4 is the possible remainder.
Possible remainders can either be 0. That means it is perfectly divisible, or it can be 1, or it can be 2. Can it be 3? No, it cannot.
Yes, sir, it can be 4 also.
How can it be 4?
That's
right.
Because
this is what I wanted you guys to understand. This is very important. How can it be 4?
Like, sir, because I say 3, like 1, 3 2s are 6, so 8 minus 6 is 2, and 2, 9, 3, 9.
Chalo, yeah. let's do it for you. Let's do it for you. Okay? 3. Okay? Tell me how you're going to divide this.
So, we need to write 2 on top of the first 8, because 3 2s are 6. And then we, then we subtract it from 6, which the answer gives us 2. Answer is 2. Then we carry forward the...
What comes here?
Yeah, 2 comes there. Then we carry forward the... No, don't carry forward, just like bring the 8 here. And then 9 on top of the second, right? 9 on the second, 8. And then you will... Sir, why have you written 8 over there? I told you to write 2 and 8. You've written it opposite.
Yeah, okay. Yeah, I probably couldn't.
Now we 3 9s are 27, so we subtracted by 27.
Good.
Then the remainder is 1.
So how did you
I got confused looking at 84 upon 3 and 88 upon 3.
Basically, wait 1 second. Yashika, yes, you have something to say?
Yeah.
Yeah, tell me, Yashika.
So, you're saying that 1 minus the divisor.
Divisor minus 1.
Maximum remainder, right?
Correct.
Sir?
Yes?
Sir, I observed one more thing, that the number like 3. Sir, the reminder is not bigger than the number 3.
Exactly. Like what I'm trying to say. The remainder, if I have to write it in the form of an equality, I will say the remainder is always less than the divisor. It cannot be equal to or greater than. Is it very clear now? If I randomly ask you what is 92 by 5, what can be the possible remainders? It can either be 0, or it can be 1, or 2, or 3, or 4. Can it be 5? No, because it always has to be less than the divisor. Is this very clear now?
Yes.
Any doubts now, guys? I've taken another example. Instead of I think some of you got confused with n, so I took random examples. I don't want an exact answer. I want to know the possible value of remainders. It is always the divisor minus 1. You can take any example and try that. You will end up with the same thing. Don't worry. Sure. Now, let's actually get into the division algorithm. Chalo, take. Let me write something over here. A is equal to BQ plus R. A and B belong to W. That is, A and B belong to our whole numbers, and B is not equal to 0. Conditions. Okay. Don't bother too much about it. Now, Q is nothing else but the quotient. R is nothing else but the remainder. Okay. And now, say A is equal to 21. Okay. B is equal to 2. A and B are whole numbers. B is not equal to 0. I have taken two numbers which satisfy this condition. Okay. And say B is nothing else but the divisor. What does the algorithm say? The algorithm says A is equal to BQ plus R. Do not worry right now. Do not worry. I'm writing so many letters. Don't worry. We will look at the example and make it.
Sir, excuse me, sir. Can I ask something?
Yes.
Sir, you have written in the box like A, B, E, W. I didn't understand it.
AB belongs to whole numbers. This is the symbol for belongs to.
Okay, sir.
That is A and B are whole numbers. 21 and 2 are whole numbers and B is not equal to 0. B is equal to 2. That means it's not equal to 0. Correct? Now, 0 less than or equal to R less than B. This is the algorithm. Now let's see how this makes sense. Let's understand it numerically. Don't worry about this. This will automatically come when you understand this. How can I write 21? Say when I divide 21 by 2, 21 by 2, 2 tens are 21. Correct? So how can I write 21? I can write 21 as 2 into 10 plus 1. Is this clear, guys? Any doubts over here?
No. What is BQ?
Relax. I will come to B, Q, R, A, B. Relax. B is the divisor. R is the remainder and Q is the quotient. Now,
okay, sir.
Now, guys, is this in the form of this? Can we draw a relationship? A is 21. That is what we had written. B is 2. That was the divisor. We got the quotient as 10. What was the remainder? 1. Remainder 1. Quotient 10. Is this clear? It's a little messy, but I hope it is clear. Do you guys understand what I'm trying to write over here? Do you now understand what BQR are? B is divisor.
Not really, sir.
Q is quotient. What was the previous one that we did? Dividend equal to divisor into quotient plus remainder. Instead of writing quotient, I've written Q. Instead of writing remainder, I wrote R. But for divisor, I wrote B. As simple as that. I just wrote 21. When 21 is divided by 2, it is nothing else but 2 into 10 plus 1.
Yes, so now I understood.
Is it clear now? Now, does this also satisfy this condition? What does this condition say? The remainder should be greater than or equal to 0. Okay. What is the remainder?
Sir, excuse me, sir.
Yes.
I understood this, but still I understood this and the before condition. But still I'm having a confusion. What is algorithm? I understood what all you have given.
This is the algorithm.
So that means A equal to BQ plus R.
Remember the divisibility theorem we just understood? Dividend equal to divisor into quotient plus remainder.
Yeah.
Same thing. He's just trying to make our life difficult. Okay. But look at what he's saying. What has been explained in the previous slide is going to be very clear in this slide. Okay. The remainder is 1. We got the remainder as 1. Correct? Even when we divided. Now, let's see if it satisfies this condition. He says 0 less than or equal to 1 less than 2. Is 1 greater than or equal to 0, guys? Yes. Is 1 less than 2, guys? Yes. It
Yes,
satisfies
sir.
the condition. Let me take another example. Say A is equal to 35, okay, and B equal to 6. We just have these two numbers. Forget about all this. Let's basically understand. I told you B is nothing else but the divisor. Instead of writing D, he wrote B. Okay, not an issue. If I divide 35 by 6, 6 5s are 30. What is the remainder? 1. Correct? Remember, if I relate it to the possible remainders concept, the possible maximum remainder can always be 1 less than the divisor. We got 5, which is 1 less than 6. Correct? Our previous funda also makes sense. Now 35 can be written as 6 into 5 plus 5, guys. Correct? A is equal to B into Q plus R, guys. The remainder is 5. What is our condition? 0 less than or equal to remainder less than B. That is 0 less than or equal to 5 less than 6. That means 5 is greater than or equal to 0 and 5 is less than 6. All he's trying to explain is that the remainder will always be less than the divisor. What were the possible remainders? Guys, what are the possible remainders that we get when we divide a number by 6? It can either be 0, it can be 1, 2, 3, 4, 5. Can it be 6? No. This is what we understood in the previous slide with the help of examples. That is exactly what he's trying to tell us by writing this. Is this now clear, guys? Looks complicated, but don't complicate it for yourself. Think very simply. Think about the division.
It's very easy.
Yeah, basically. So basically,
Sir, that means very much easy. Just about very much easy, but looks a bit complicated.
right. I want you to understand the funda of possible remainders. That is very important. If I tell you guys, there is a random number n and it is divided by 7. What can be the possible remainders? What is the answer? There's a number that is divided by 7. What are the possible remainders, guys?
0, 1, 2,
Jaldi,
3,
yeah.
4, and 6.
4, 5 and 6. Can it be 7?
No, sir.
Why can't it be 7?
Because, sir, if the remainder is 7, it can be divided by 1, and that could be 0 then.
Exactly. When the remainder is 7 and if I'm again dividing it by 7, I'm getting the remainder 0. So maximum possible remainder can only be 6. Yashika, do you have a doubt? Is everyone clear with the concept? If anyone has a doubt, I'm going to repeat it again. It's very important. Division theorem, algorithm, whatever you call it, it's very important.